So with the last burnout test, the front brakes failed. It's a good thing for the YouTube channel because now I can show you how the front brake system works and the weakness of the parts when you're trying to do burnouts with big rubber tires on tar seal or tarmac sealed road. The amount of force going through these parts is huge, so these types of parts they can't handle it. So today I'm going to make up a steel center diff. So this is the center diff, and this is the secret of how it all works. So it goes around like that, this being the rear, that goes to the rear diff, and that goes to the front diff. And you can see I've put a bit of rubber in here, and then you've got the disc brakes there. So the servo obviously clamps down and locks the front wheels. And this is all custom made because it's originally designed to drive the front wheels, because this was originally a four-wheel drive vehicle. So this is the magic. This is where I've altered things to make it a rear-wheel drive vehicle. And this is the secrets inside here, which I'm about to show you. But what's happened is there's so much force going through here that it's just completely shredded. It's just shredded that plastic part. So I'm going to make a new part out of stainless steel. But it's a bit of work. There's welding involved in it. And then little intricate parts like this, which is essential, that goes into that bearing, will have to be welded into the new stainless part. So it's a bit of a mission, but it's got to be done to make it strong so it can do those burnouts. So let's get into it. So this is the secret to the center diff. I made up this steel disc here, and that's got a pin going through it, and that's fixed to this main gear that the main motor, the motor spins this main gear, but it's locked, so it's essentially a lock diff. Remembering this is the center diff, which drives the rear drive shaft. And then that's the center diff there. That used to have differential gears in it, so that's all been taken out. Now that just goes onto there. And then this, taking the diff gears out of here, allows the front wheels to spin freely, and that's the secret of how it all works. But it's still got the brakes on it for the front, and that's how I'm able to brake the use front brakes, also at the same time allowing the rear wheels to spin. So that's just what that looks like inside. So by the time this is finished, I'll have a stainless one of these, because you can see that's just getting shredded. Okay, so that little piece is now welded inside there. So that's TIG welded in there. With 40 amps, low amps. And then so that piece there will now get welded onto there, and you can see it's starting to take shape. So that, when I've welded that, I think it's expanded. So it was, I couldn't get it inside, so I just had to file that face down to let it go inside that bearing. But now it goes inside, it's a nice fit. So that spins on that bearing. Remember, this used to be plastic, now it's steel. So we're making it stronger. And then this is the front brake section of the centre diff. So that bearing fits inside there. And then that spins. And you can see it's starting to take shape. So that will end up getting welded on there like that. So that's all steel now. Whereas before, it was that plastic one. That was all plastic. Sorry. Okay, I got a bit carried away with the welding, so but there's the update. So it's all welded up. It's still got water in it from cooling it down. So the next step is to drill some holes in here, and that's to bolt it so I can bolt or screw it. That's the next step, is to screw that onto there like that, and you can see it's coming together quite nicely actually. So the bearing, so that bearing goes in there, and then that goes in there. That should just clip into there. Right. So that's how to make a stainless centre diff. And then that will screw onto there like that, and yeah, it's all seems like it's good so far. We'll know when I go to test it. Okay, so there's the finished part. Custom made stainless steel centre diff coupling. So it's got those holes in there for inspection so I can see what's happening inside, but it's also a bit of weight reduction. Those are they're actually they're like an M3. They're a UNC thread. They're about they're equivalent to an M3 screw going in there. I used a UNC because that's the pitch is a bit coarser, so it should be a bit stronger. So yeah, that's how it come out. So I'll screw it all together and we'll have a look at it. So one of the critical thing is this bearing here. So this bearing fits on there like that, and that allows it to spin, free spin. So when the back wheels are spinning, this will spin very fast, and it will allow the front wheels to be locked while the back wheels still spin. Okay, so that's the finished part. couple of things I had to change along the way, like putting that, there's a roll pin in there to stop the nut from coming off. But that's the part. So that can spin. So that will spin the back wheels, and this part here will stay still. And that's for the brakes. That's for the brakes to work and allow the back wheels to spin. So yeah, a bit of a mission to make that up, but I think it'll be well worth it, because I was having a lot of problems with this part just being made out of plastic. It's just not strong enough. So these are the parts here. So that's what happens if you try to do burnouts with big wheels with plastic parts. They just can't handle it. So that's a new piece. That's what a new one looks like. So I've used this is a metal part here. I've taken that out and put it into the stainless tube. So I'll get it fitted back into the Proper RC Burnout Truck, and then I'll go and do some testing. Okay, so it's fitted back in the truck. So that's it there. And then if I spin that, so you can see it's actually a bit tight at the moment, but I'm hoping that it loosens up. But that gives you an idea of how it all works, because you don't normally see any of this because the batteries go on top, so you wouldn't get to see how it works. And then this servo here is connected to these brakes, so that's what locks that. It's a bit hard to see, but so you can see that can spin. See that nut spinning inside? So that's how the magic happens. So that's it all back together, and once the batteries are on, it's very hard to see inside there, but I've got the servo hooked up to the little button on the controller here, so when I push that activates the servo, which locks those brakes inside there, and it's working well. So that servo is a OMG 55 kg in the end. I had to go with a big one because the last one burnt out. It was only 20 kgs. So this is a really good quality brushless servo. And then I've got the 65 kgs OMG servo for the steering, which also needed to be very heavy. It's all about those massive wheels. And so I do expect the rear wheels to smoke. That'll be a good day when those tyres start smoking. Just you can see that's all welded aluminium inside there, because you can't use plastic hubs on something like this. That they just shredded just like the other plastic parts. So ready to do some more testing now, so that'll be test number 3, and we'll be doing that in that'll be the next video.